All right, chapter 15 worksheet, correlation. Question 1 is asking you, what correlations do these scatter plots represent? So A, you could see there is no linear trend. All the dots are scattered all over the place. And when you see that, you can assume there is no correlation. For B, you could see how the scatter plot starts to move one way, then curves up in another direction. When you see that, it's called curvilinear correlation. When you see scatter plots go from left at the bottom to right at the top, as right here, you know it's a positive correlation. And the closer the dots are to each other, the stronger the correlation is. So here, they're not too far apart. They're not that tightly packed in. So this is a medium positive correlation. On this scatter plot, you could see it starts at the top left and moves down to the right. On scatter plots like this, you know that that's a negative correlation when it starts from the top left and goes to the bottom right. And you see how the dots are very close together. So you know that means it's a strong correlation. So this will be a strong negative correlation. On E, again, there's no linear trend. The dots are scattered all over the place. This represents no correlation. And here, you could see it goes from the bottom left to top right. The dots are pretty close together. So this would be considered a strong positive correlation. All right. Another thing that you should understand about correlations is one outlier can affect your R-score. Your R-score is also known as your correlation score. So if one data point is far off from the others, it can greatly affect your correlation. So outliers significantly influence correlations. As far as correlation coefficients and knowing how much larger one is than the other, you simply calculate the effect size. So in this case, let's say you had an R of 0.4 and you square it, that would be an R squared of 0.16. And if you had an R-score or a correlation score of 0.2 and you square it, you would have an effect size of 0.04. 0.16 is 4 times larger than 0.04. R squared is simply the correlation squared. So once you solve for R, you square that, and that is how you find the effect size, defined as the proportion of variance accounted for. All right, let's go on to the questions. 4 young children were monitored closely over a period of several weeks to measure how much they watched violent television programs and their amount of violent behavior toward their playmates. All right, you have child A, B, C, and D. All right, the TV hours watching violent television are plotted here, 14, 8, 6, and 12. And the acts of aggression towards their peers are plotted here, 9, 6, 1, and 8. This is the data that you will use to solve the correlation, to see if there's a correlation, an association, or a relationship between TV hours and acts of aggression, or TV hours watching violent television and acts of aggression towards their peers. If you plot these, you could see that it moves from left to right. And if you drew a line right here, you would see that these dots fall very close to the line. So based on its movement from bottom left to top right, you know that's a positive correlation. And because these data points fall close to each other, you can assume it's a strong correlation. Now, this is not how you solve the correlation. This is a good way to know what you're looking for once you solve. So you should be getting a positive number, and it should be high. Correlations go from -1 to 1. All right. -1 is a perfect negative correlation, and a +1 is a perfect positive correlation. A 0 means no correlation. All right. Anything from 0.1 to 3 would be considered a weak correlation. Anything from 3.1 to 7 would be considered a moderate or medium correlation. And anything 7.1 to 1 would be considered a strong correlation. All right, most likely you're not going to get a 0 when you solve a -1 or a 1. Your answers will fall somewhere in between -1 and 1, but not at -1 or 1, and most likely not 0. So you could see here, just by looking at this data, you could assume that it is a strong positive correlation. But what is that exact correlation number? Well, this is how we solve that. We're very familiar with sum of squares. So within this is the definitional formula of sum of squares. So right here, you plot all your x's, and then you get the mean. So if you add 14 plus 8 plus 6 plus 12 and divide by 4, you will get 10. Now you're going to get all the deviations from the mean. Sound familiar? 14 minus 10 is 4. 8 minus 10 is -2. 6 minus 10 is -4. And 12 minus 10 is 2. Now you have your 4 deviation scores. Next, you square those numbers, you add them up, and you get the sum of squares for variable x. Move on. Now, you're going to plot for y. So y here is acts of aggression. You are going to plot 9, 6, 1, and 8. If you do 9 plus 6 plus 1 plus 8 divided by 4, you will get 6. 9 minus 6 is 3. 6 minus 6 is 0. 1 minus 6 is -5. And 8 minus 6 is 2. You then square all these numbers. 3 squared is 9. 0 squared is 0. -5 squared is 25. 2 squared is 4. You add them up, and you get 38. All right, this should all be very familiar. This was one of the first lessons that we did in the first month of class. All we're doing here is getting sum of squares for 2 variables. So there's really only one new step that you have to understand, and that is finding SDP, the sum of the deviation products. So what you do there is you take the deviation scores. So let's say for the first child. So the first child's deviation score from the mean is 4 for variable x. For variable y, it's 3. So 4 times 3 is 12. Same thing for the second child. That would be -2 times 0 is 0. Third child, -4 times -5 is +20. And for the last child, it is 2 times 2, which equals 4. Now, when you get all these values, you add them up, and you get the sum of the deviation product score. That is 36. Now, all you do to get R is you take SDP, which is 36, and you divide it by the square root of SSX times SSY. SSX is 40, SSY is 38. So when you put this into your calculator, you will get a score of 0.9233. Strong positive correlation, right? That goes with what graphically it looks like before we even calculated it. Now, what is not asked here is what is the effect size, or what is the proportion of variance accounted for. All you do is square this number. So on your test, if you're asked what's the effect size or what is the proportion of variance accounted for, you just take 0.9233 and square it. We'll also go over the next question. 4 research participants take a test of manual dexterity. High scores mean better dexterity. And an anxiety test, high scores mean more anxiety. The scores are as follows. 4 participants, labeled A, B, C, and D. Dexterity scores are 1, 1, 2, and 4. And anxiety is 10, 8, 4, and -2. If you go down and plot those points, you could see that it moves from top left to bottom right. When you see that, you know it's a negative correlation. Now, if you drew a line, they all fall pretty close to each other. So after you calculate the correlation, it should be a negative, and it should be a pretty strong correlation score as well, right? So the general pattern here would be a strong negative correlation. But we don't know for sure until we do the actual calculations. So again, you plot all the x's in a row, and then you get the mean, right? 4 plus 2, 6, plus 1 plus 1 is 8. 8 divided by 4 is 2. 1 minus 2 is -1. 1 minus 2 is -1. 2 minus 2 is 0. 4 minus 2 is 2. Square all those values. Sum those squares up. You get 6. Then you plot the y's. You have 10, 8, 4, and -2. The mean of 10 plus 8 plus 4 plus -2 divided by 4 is 5. 10 minus 5 is 5. 8 minus 5 is 3. 4 minus 5 is -1. -2 minus 5 is -7. Now, you square those numbers. 5 squared is 25. 3 squared is 9. -1 squared is 1. -7 squared is 49. Add those numbers up. You have your sum of squares y. Finally, you want to get the sum of the deviation product score. So you look at the deviation numbers, which is the values that you get when you take x and subtract it by its mean, and you multiply them. So -1 times 5 is -5. -1 times 3 is -3. 0 times 1, 0 times -1 is 0. And 2 times -7 is -14. -5 plus -3 is -8, plus -14 is -22. All right, we have everything we need now to solve for the correlation. Take -22 and divide it by the square root of sum of squares x times sum of squares y. Sum of squares x is 6. Sum of squares y is 84. So -22 divided by the square root of 6 times 84 equals -0.9799. Now, just like we saw on the graph where we knew it had to be a negative correlation and probably on the stronger side, we could see we have a very strong correlation of -0.9799. Now, if I asked you what proportion of variance is accounted for by the two variables, you would simply square this number to get the effect size, right? We're solving for R, and we learned when doing t-test that R squared equals proportions of variance accounted for. So here we already have R, so we're just going to square it, and that's how we get the effect size. This is the process on how to calculate a correlation manually. If you have any questions, feel free to email me, and good luck.